Yes, is this audible? Yes, Dania.
Yes, ma'am.
Zaid, are you there in the meeting? All right, Dania. Let's continue. So we had completed the basic definitions of electric charge. Now we are going to start Coulomb's law. What is meant by Coulomb's law? So see, Coulomb's law, if you have two charges, let's say Q1 is one charge that you have, Q2 is another charge that you have. And the separation between these two charges is, let's say, small r. So according to Coulomb's law, according to Coulomb's law, Coulomb law says that electric force, this is directly proportional to product of magnitude of both the charges. So if you have Q1 as one charge, if you have Q2 as other charge, so Fe will be equal to Q1 multiplied by Q2. Means the product of both the charges. If your Q1 is -4, Q1 is, let's say, Q1 is -4 Coulomb, Q2 is 3 Coulomb. You have to consider only the magnitude. So considering only the magnitude makes it 4 multiplied by Q2, that is 3. So 4 multiplied by 3, that gives us 12. So it means product of charges you have to take. Apart from this, this electric force is inversely proportional to square of radius. So if I combine both these factors, I can say electric force is directly proportional to product of the charges and inversely proportional to the square of the distance separating both these charges. Now see, whenever we have proportionality sign, that gets removed with the help of a constant. So the constant that is used in case of Coulomb's law, the constant that is used, we represent it through K only. So this is a constant that we use. F is equal to K Q1 Q2 divided by R square. This is the constant that we use. F is equal to K Q1 Q2 divided by R square. Now see, this formula that we are getting, K multiplied by Q1 multiplied by Q2 divided by R square, this is known as Coulomb's law. This is the formula. So I am repeating it once again. What is Coulomb's law? Coulomb's law says that if you have two charges, both the two charges are separated by a certain distance, then the electric force is given by the product of the magnitude of the two charges. Like if you have Q1 and Q2 with you, so product of the two charges magnitude means what? Q1 multiplied by Q2. So electric force is firstly proportional to this. Secondly, electric force is inversely proportional to the square of the distance separating them. This is what is the definition of Coulomb's law. What is meant by Coulomb's law? Now see the constant that we use. We have certain value of this constant. We write this constant as 1 divided by 4 pi epsilon naught. This is the value of the constant that we have. So see, electric force is also a force. So the SI unit will be Newton only. Now what is meant by this? We'll understand what is this. First, we'll understand what is this epsilon naught, then we'll be able to put what is meant by this. So before we go on to this, understand what is this. This symbol is called epsilon. The symbol is known as epsilon. It is the absolute permittivity of a space. This is known as absolute permittivity of space. Now say if I say this quantity does what? This governs the relationship between force and the medium. For example, I have the two charges kept in air. Force is 2 Newton. Then I take those two charges and I put them in water. Now the force will be something else. It won't be 2 Newton because the denominator has changed, permittivity has changed. So this relationship between the force and how it is related to the environment, how it is related to the medium, this is given through epsilon. Now if I specify the absolute permittivity of free space, absolute permittivity of free space means air or vacuum or mainly free space. This means I am talking about air. So there is certain value of permittivity for air which you have to remember. Different media have different value of permittivity, for because of which there are different values of force. Now you have different values of epsilon naught, but you don't have to remember each of them. You just have to remember this one, epsilon naught. There are so many epsilons: epsilon R, epsilon G for glass, epsilon W for water. There can be any value for epsilon, but you have to remember epsilon naught means absolute permittivity for air or vacuum, whose value is 8.85 into 10 to the power minus 12 Coulomb square per Newton per meter square. This is the value of absolute permittivity of free space. Free space means your air or vacuum. Now, if I put all these quantity, what was my K? K was 1 over 4 pi epsilon naught. In this, 4 is already a constant number. Pi is 3.14. I know the value of pi. What was unknown over here? Epsilon naught I didn't know. So now I will be able to calculate this K. This will be equal to 1 divided by 4. Pi is what? 3.14. And epsilon naught is 8.85 into 10 to the power minus 12. So if you will solve that, you will get K as 9 into 10 to the power 9 Newton meter square per Coulomb square. This is what is known as your Coulomb's law. So this is your epsilon naught is your absolute permittivity of free space and the value of the constant that we get. This is 9 into 10 to the power 9. Is it clear, Dania, Yusuf? Yes, Yusuf and Dania.
Yes, ma'am.
Yes, ma'am.
All right, so just note it down. Yes, Shehbaz, this is your first class, no?
Yes, ma'am. It's my first class.
Okay. So, Shehbaz, we had started with electric charges and fields. in your first unit, that is electrostatics. So we had discussed what is electric charge. So we discussed that electric charge is the intrinsic property of matter and that transfer of electrons occur. So the body that gains electrons becomes negatively charged and the body that loses electrons becomes positively charged. And today we have started with Coulomb's law. Coulomb's law says that if there are two charges kept, Q1 and Q2, these are two charges kept with a certain separation between them, then electric force is directly proportional to the product of the magnitude of both the charges. Q1 multiplied by Q2. Fe is directly proportional to Q1 multiplied by Q2. Apart from this, electric force is inversely proportional to the square of distance between them, square of this distance separating between them. So this is what is meant by Coulomb's law. These are the two statements. First statement is this: electric force is directly proportional to Q1 and Q2, and second statement is electric force is inversely proportional to square of distance between them. Yes, done?
Yes, ma'am.
All right. Now let's see some properties of Coulomb's law. So this was Coulomb's law, where electric force is firstly proportional to product of the magnitude of the charges and secondly inversely proportional to the square of distance between them. So the constant that you use, K, this value is 9 into 10 to the power 9, which you have to use. So we'll be doing questions through which that will get clearer. Now certain properties of Coulomb's law. First property says that it is valid only for point charges. So even if you have spheres, you can use them, point charges or spheres. So if you have 2 point charges like Q1 and Q2, or you have two spheres with you having the charge Q1 and Q2, and both of them are separated by certain distance, and you can apply Coulomb's law. Coulomb's law will be valid over here. Now the second condition, not the condition or the second property for it. It says that distance between them should remain the same, as in both the charges should be at rest, or at least one of the charges should be at rest. So it is valid only if both the charges, it is valid only if both the charges are at rest, or at least one of them is at rest. At least one of them is at rest. So when one of them is at rest, what should happen? Distance between the charges should not change. If this condition is getting satisfied, distance between them does not change. So for example, you have plus Q1 with you. All right. This is the stationary charge. One should be at rest. Let's say Q2 is moving. So Q2 should move in such a manner that the separation, that the distance between Q1 and Q2 remains same. If Q2 moves in a circle, then the radius of the circle or the radii of the circle, this should be the same. So we can say that Coulomb's law can be applied even if Q2 is moving, but Q1 should be at rest. The third property says that it is a conservative force. Coulomb's law, it is a conservative force, means that work done does not depend on the path traveled. It is path independent. It just depends on the initial and the final point. So it is a conservative force. And the last property, that it is a central force. These are four basic properties of Coulomb's law. First, note it down, then I'll give you a question based on the formula that we have done, K Q1 Q2 by R square. Just note down these properties first. See, how do we solve this question? You are provided with two charges. One is plus 2 microcoulomb, other one is minus 3 millicoulombs. The separation between the charges is 3 millimeters. You have to calculate the electric force. So see, the formula of electric force is what? K, Q1, Q2 divided by R square. So the value of K, constant that you get, this is 9 into 10 to the power 9. Q1, let's talk about this charge, Q1. This is what? This is 2 microcoulombs, but we always use it in terms of the SI unit. So you have to convert the CGS or the whatever unit is given to you. Micrometers, you have to convert it into meters. So you have to multiply it by 10 to the power minus 6 to make it into coulombs, that is the SI unit. This is Q1, then your charge Q2. This is minus 3 millicoulombs. So we won't be considering this negative sign. The reason is that only magnitude is taken, and whenever we take the magnitude, no charges, no sign is taken, be it positive or negative. So we'll be only talking about 3 millicoulombs. Now see, again, millicoulombs is not the SI unit of electric charge. What is the SI unit of electric charge? It's coulomb. So this gets converted 3 into 10 to the power minus 3 coulombs. Now you have the value of K, Q1, Q2. R, separation between both the two charges. This is 3 millimeters. So the SI unit of the distance or the separation is what? It's meter, unit of distance or length. So 3 millimeters is not the SI unit that we can utilize. So we first have to convert it into meters. 3 millimeters will be 3 into 10 to the power minus 3 meters. This is 3 millimeters. So now you have all the quantities in SI unit, standard unit. Now you can put all the values in the formula of force. K is 9 into 10 to the power 9. Q1 is 2 into 10 to the power minus 6. Q2 is 3 into 10 to the power minus 3. R square means 3 into 10 to the power minus 3 into 3 into 10 to the power minus 3. I've written it twice because it is R square. So you have to multiply it 2 times. 3 into 10 to the power 3. This gets cancelled. This becomes 3. 3 multiplied by 2 gives 6. This becomes 9 plus 3. This is 12. 12 minus 6 is 6. 10 to the power 6 Newton. This is the force that you will get. That's how you utilize this formula. F is equal to KQ1 Q2 by R square. So quickly note it down. The other question I'm giving you, you should try that question by yourself. At least note it down and try that question. Yes, try this question. Two charges Q1 and Q2 are placed at separation R. So what will be the force? Then multiple the charges and half the separation, and then see what force is coming. Take the ratio of both the force and submit your answer quickly in the chat box. Just try this question, simple, using your Coulomb's law. See how we solve these kinds of questions. If you have two charges, Q1 separated from Q2 by a distance R. So F will be equal to what? F will be equal to K Q1 Q2 by R square. This is according to Coulomb's law. Now what does it say? It says the new charges have the magnitude doubled. If these are the two charges, then now it is 2 times Q1 and now it is 2 times Q2. And the separation is halved now. So this means this is R by 2. So the new force that you are getting, F prime, this is equal to what? K. The charge is now 2Q1. The second charge is now 2Q2 divided by R by 2. R by 2. So 2 will go over here. So this becomes 2Q. 2 into 2, 4. 4 into 2, this is 8. Okay, no, we'll square it also. R square. We have to square this. So R square will be what? R by 2 whole square. This is R by 2 whole square. So this becomes R square divided by 4. So R square and 4 goes over here. So F prime becomes 16. K Q1 Q2 divided by R square. Now see, if you take the ratio between force F and F prime, F divided by F prime will be what? F is equal to K Q1 Q2 by R square. F prime is 16K Q1 Q2. So R square, Q1, Q1, K cancel. You are left that F prime is equal to 16 times the original force. Just note it down. This is the solution. So we had discussed a little about what was epsilon naught and the constant. Let's discuss it in a bit detail. What is dielectric constant or the concept of relative permittivity? The constant of dielectric constant, what is meant by it? So now see, as I've told you, force in air is given by what? 1 by 4 pi epsilon naught. The value of K in air is what? This epsilon naught that we put. Q1 multiplied by Q2 by R squared. This is the force in air. Now, if you shift the medium, if there is some other medium, these charges are initially, this is kept at Q1, this is Q2. Both of these charges have a certain separation R in air. Now another medium is taken. This is Q1 charge, this is Q2 charge. So now F force in the medium, this will become 1 by 4 pi epsilon Q1 Q2 divided by R square. You don't put epsilon naught now. Why? Because epsilon naught is placed in terms when you have to know what is the medium. So epsilon naught is put when you have air as the medium. Epsilon is general. But see, we can establish a relationship between epsilon naught and epsilon. If you take the ratio of epsilon by epsilon naught, this is equal to the K that we use 9 into 10 to the power 9, the constant in Coulomb's law. This is known as dielectric constant. This is known as dielectric constant. Or there is one more relationship. F medium is equal to F air divided by this dielectric constant. So these are two relationships between dielectric constant and permittivity, and dielectric constant and the force in different mediums. So this can be written as F in air by F in medium, whereas epsilon in air divided by epsilon in free space. All right, so this is what is meant by absolute permittivity. Just note it down, this point, these 2 points as well. Then we'll begin with electric field. Yes, done? Yes, Dania, Shehbaz, have you written it down?
Yes, ma'am.
Now see, the next topic that we have is electric field. So what is meant by electric field? See, if you have a charge with you, plus Q is a charge with you, so it will be generating certain field around itself. So what happens? We take this charge Q, we call it as a source charge. We call it as a source charge. So this is a stationary charge. This source charge, this is a stationary charge. This does not move. Source charge has a space around itself. Now, if we bring up another charge, let's say plus Q we have brought. If we bring this charge plus Q nearer to the environment of this proximity of the source charge, we'll feel certain phenomena like phenomena of repulsion or phenomena of attraction. So this confined space where electrical phenomena of this test charge can be experienced. That field or that space, that is known as the electric field. This charge is known as the test charge. This is called as a test charge. Whereas this stationary charge is known as the source charge. So this stationary charge produces a certain field around itself, a certain environment around itself, where electrical phenomena can be experienced. Electrical properties, different electrical properties. Like if I bring up a negative charge closer to the positive charge, then it will get attracted. If I bring up a positive charge to the positive charge, like the case that is in front of us, both of them will feel forces of repulsion. So the test charge, when we bring it near this experiences a force. Both of them will experience a force though. So electric field is what? Electric field is the property, it's a property of a single charge. A single charge is enough to generate the electrical field. Like in case of electric force, what happened? We required two minimum forces. Both the two forces exerted force on each other, so electrical force phenomena occurred. If you have for electric field, a single charge is enough. If you have electric field, if you have a single charge, that single charge will be having certain field around itself. That space around that single charge, we called it as electric field. So see, what is meant by electric field? It is the space around the charge in which electrical properties can be experienced. So see, since no contact has been made between these two, between the charge, test charge, and the source charge, so we say it is used to explain non-contact forces. To explain non-contact force, concept of electric field is required. The concept of field is required. So what is meant by electric field? I'm repeating again. See, electric field is what? A single charge produces certain space around itself in which various electrical phenomena can be experienced. So this space, confined space around the charge, is known as electric field, and it's a property of at least one charge. It's a property of a single charge. It is a property of a single charge. Okay, Danya, tell me one thing. What is the speed of light? Yes, Danya, what is the speed of light? Yes, Danya.
Yes, ma'am.
Yes, what is the speed of light? Do you remember?
No, ma'am.
See, speed of light is 3 into 10 to the power 8 meter per second. So electric field also travels with the speed of light. So electric field travels with the speed of light. So remember the value of speed of light. Speed of light, this is 3 into 10 to the power 8 meter per second. So electric field travels in this manner. All right. So just note it down, then we'll see what is electric field's intensity. Written?
Yes, ma'am.
Now see, let's do what is meant by electric field strength or intensity. Now see, electric field strength or electric field intensity, this is also known as electric flux density. Now again, I have the source charge, capital Q, this is the source charge. At this point A, I have taken plus Q, this is the test charge. So this experiences certain force, Fe, and let's say electric field is directed in this direction. Now see, all the electrical force, whatever electrical force will be experienced by this small test charge, we'll call it as electric field. This another definition of electric field. Electric force, Fe, experienced by what? By this test charge. Experienced by test charge small q due to field of the source charge. Field of the source charge. This is known as electric field intensity. Whatever will be the force experienced by this test charge, we'll call it as electric field intensity. So this test charge will be experiencing force due to what? Due to the source charge only. Capital Q will be exerting force on small q. So this small q, this test charge, this experiences electrical force. These electrical forces experienced by this test charge, we call it as electric field. So if I rewrite the definition of electric field will be equal to what? Limit q tends to 0 F by Q. Electric field is limit q tends to 0 F by Q. So basically electric field is what? Electric field is F by Q, force divided by charge. This is electric field. But why we are putting this limit tends to 0? So that the force experienced by small q, this is negligible. Otherwise capital Q won't be stationary. So limit q tends to 0 has been put so that force exerted by small q is negligible and hence capital Q cannot move. Capital Q cannot move because this is our source charge and we want it to remain stationary. We don't want the source charge to move. That's why we have written it as limit tends to 0. Apart from these, there are a few points that you have to remember regarding electric field. Electric field is a vector quantity. If you remember what are vector quantities, electric field is a vector quantity. It means it has direction, it has magnitude both. In case of scalar quantities only have a magnitude. They don't have any direction. So electric field is a vector quantity. It means it has both magnitude as well as direction. So its direction is same as whatever is the force experienced by the test charge. Its direction is same as that of force experienced by test charge. So, Dani, if you remember the SI unit of force, SI unit of force is Newton and SI unit of charge is Coulomb. Electric field is what? Electric field is force by charge. So, for force we have what? Force we have SI unit as
Coulomb.
Newton per Coulomb. Perfect. This will be Newton, this will be Coulomb. So SI unit will be Newton per Coulomb. Also, we have it as volt per meter. But how can we get it as volt per meter? We'll discuss later on. In the next chapter, potential and capacitance, there is a reason why do we call it as volt per meter. But you have to remember there are two SI units of electric field, either Newton per Coulomb or volt per meter. One more thing, if I'm writing it as electric field is equal to force by charge. If I put charge as what? Plus 1 Coulomb, then electric field will directly be equal to force because now the denominator has become 1. So it means we have got another definition of electric field. Electric field is the force experienced by what? A unit positive test charge. A unit positive test charge. This is what is meant by electric field. All right, so just copy these points of electric field as well. Now see, if you get questions directly, how will you solve it? If I say that a test charge of 10 to the power minus 3 coulombs, it experiences a force of 10 to the power 2 Newton due to field of a source charge. Then calculate magnitude of field. Now see, force is given as 10 to the power 2. Charge is given as 10 to the power minus 3. Electric field is what? Electric field is force per unit charge. Force is 10 to the power 2 divided by 10 to the power minus 3. This 10 to the power minus 3 will become 10 to the power positive 3 as it will go in the numerator. So electric field will be 10 to the power 5 Newton per Coulomb. This is the answer. Okay, just note down this question as well. See, it says a point charge of 10 Coulomb is placed at origin. Calculate electric field at point A. And the point A is given to you at 3, 0, 0. It means this is your origin. At origin plus 10 Coulomb has been kept. At this point is A point. 3, 0, 0 means this is 3 meter. You have to find out the electric field. So for a positive charge, electric field is always away. This will be the direction of electric field. So electric field will be what? Remember, for a positive charge, electric field is directed away. For a negative charge, electric field is directed towards the charge. So since it's a positive charge, we have to run away from it. This will be electric field will be in the along the positive x-axis. Now let's find out the magnitude of it. Electric field will be what? Electric field will be force K Q divided by R square. This is electric field for a point charge. So this we'll discuss in detail how this has come, KQ divided by R square. Okay, let me tell you this only right now. See, force is what? F by small q. This is electric field. Electric force is Q divided by Q. R square, this is electric force. This is electric field. So QQ gets cancelled. This is the formula of electric field for a point charge. This is electric field for a point charge. All right. So in this formula, if we put K is 9 into 10 to the power 9, Q is given to us as 10 coulombs. R square means 3 square. That is 3 into 3, which is 9. So electric field is what? 10 to the power 10 I cap, because it is directed towards the positive x-axis. Is it clear, Dania?
Yes, ma'am.
All right. Note down this question as well. And when you are done, when you have written it down, just let me know. Just text me done or just unmute yourself and say done. Yes, Dania, have you written it down? All the points?
Yes, ma'am.
All right. So let's stop it today. We'll continue next week. We'll begin with whatever